Okay, so we're going to find the first time that they both start over in the same place. So again, what we're doing here is we're trying to figure out what the period of this big ugly equation is. So we know the period of the first part is 2 pi over 3. So I'm going to go ahead and write out a few of these. 8, 10, 12, 14. Okay, so there's a few of those. Those are the places this guy starts over again. Now, what about this one? Where does he start over again? Well, he starts over again at 2 pi over 5, 4 pi over 5, 6 fifths, 8 fifths, 10 fifths, and so on. Now I'm going to stop there because what happened when I got to 10 fifths? That's 2 pi. And Taylor noted, and I don't know if this is true or not, I don't remember, she said a lot of the answers for those of you that did the homework did turn out to be 2 pi. That's fine, that's okay. That's what this one does. These guys overlap at 2 pi for the first time. So their period, the period of the sum would be 2 pi. Okay? All right, now let's go ahead and finish the sketch that we were going to do from yesterday. I would recommend those of you that haven't done the 4-6 work, get it done. It is easy. Get that done. So that one is finished. Here we go. We are sketching this equation. And yesterday we had done everything but the sketch. So yesterday we filled in all the information. Let's go ahead and do it again. Amplitude, period, phase shift, vertical shift, and frequency. Now, remember phase shift is the same as horizontal shift. So don't be confused if on the next review sheet I have horizontal shift written there. They are the same thing. So we had figured out that our amplitude was what? 3. Our period was 2 pi divided by 2, which is pi. Our horizontal shift is right, pi over 5. It's okay to put positive pi over 5 because positive means right. Negative would mean left. Vertical shift, we don't have one because there's nothing on the end here. Those of you new to this goes way back to chapter 1 when you talked about moving graphs around, translating graphs. If you put a number on the end of it, that picks you up or drops you down. And this was brand new to everybody yesterday. How do we find the frequency? Very simple. It's the reciprocal of the period. So if the period's pi, the frequency is 1 over pi. Okay, now we're going to sketch it. What's it going to look like? Well, I like to, maybe up in the margin or over to the side or on a scrap piece of paper, draw what it is, just the basic picture. So this is a negative cosine, an upside down cosine. So an upside down cosine looks like that, right? Now, those of you new to the class, if you don't know what those look like, well, actually you should because they're BFFs. So we all should know what those look like. So that's an upside down cosine. Now here's the problem. I'm not just going to draw that right here on my big graph because this upside down cosine doesn't start here. Remember, we shifted it horizontally, which means it starts here. Right there is where it starts. Thank you, Deandra. Okay, so I'm going to go ahead and draw it. Now, why does it start there, guys? Because you told me the phase shift, or the horizontal shift, was pi over 5. So you picked this picture up right here, and you moved it over pi over 5. So now this point is at pi over 5. Notice I've got it going up 3 and down 3 because that's what we decided the amplitude was. Amplitude is height. Now, The period is the distance between my hands. That is one period. What did you tell me that period was? You calculated it and you said it was pi. So from here to here is pi. Now don't you dare label this pi, that's not right. Right? The distance from here to here is pi. So how am I going to figure out where that is? It wouldn't be 2 pi over 5, but you're on the right track. You just did it wrong. 6 pi over 5. We need to get a common denominator when we add. When we add, we're going to take our pi over 5 and add pi to it. So pi over 5 plus pi isn't 2 pi over 5. That would be pi over 5 plus 5 pi over 5. Or 1 1/5. You could think about it as 1 1/5. This distance is pi. So how did we find our ending point? We took our starting point and added our period to it. Okay? Now the arithmetic's going to start, because now we need to find the midpoint. A negative cosine goes from bottom of valley to bottom of valley. That's a period. The hill is right in the middle. Does that make sense to you? So you have to label that. So you need to find the point that's right in the middle of 1/5 and 6/5. You need to find the midpoint of 1/5 and 6/5. You need to find the average of 1/5 and 6/5. How do we average? Add them up and divide by 2 or multiply by a half. Right. So what's 1/5 and 6/5? 7/5. That would be 7/5. Then I take half of it because I'm dividing by 2. When you do an average, you add them and divide by 2. So this guy is 7/10 pi. Fun's just beginning. Now we have to find your zeros, your x-intercepts. So what can you tell me about this one? It's the average of 1/5 and 7/10. So 1/5 and 7/10. I'm finding the average of these two numbers. So 1/5 and 7/10. Let's see, get a common denominator, add them. So this would be 9/10. But I need half of it, right? So that's going to be 9/20. Right. Now I need this one. How am I going to find that one? Same way. It's the average of 7/10 and 6/5. I'm going to average these two. I'm going to find their midpoint. Midpoint is average. So getting my common denominator, that will be what? Is that 19/10? Yeah. And don't forget, you need to take half of it, so it'll be 19/20. You can multiply it by a half. When you find midpoint, you average. You add and divide by 2. Since I've got fractions, I'm going to add and multiply by a half. A little chilling in here today? Okay, we all right there? Okay, one more. We're going to go ahead and finish this one. This sketch. This is a tangent. Now, the tangent is not a BFF. So I will put for those new, and just to refresh the rest of your memories, I'll draw a regular tangent curve here. This is our tangent. This is what a tangent curve looks like. Now, it does actually look like a BFF. Which BFF does it look like? Looks like the cube, doesn't it? The only thing is the cube doesn't have the asymptotes. The cube just goes and goes and goes. The tangent's got these asymptotes kind of holding it in. All right, so we are sketching 1/2 tan 1/3 x. Now, has there been any shifting here? Any shifting either horizontally or vertically? Does this thing have any kind of shift? No. How do I know that? By looking at the equation, how do I know that? There's no plus or minus. Thank you, Jared. Nothing's been added or subtracted. The only way to translate a picture, and that means pick it up and move it, the only way to move it, to translate it, is to put an add or subtract in the problem. I didn't. So this one is going to be situated exactly the same as a normal tangent. There it is. Now, what has changed? Well, I put multipliers in. So what do multipliers do? Stretch and shrink. That's exactly right. So, first of all, I don't know where these asymptotes are, but they've been moved because this picture's been altered. We've already said there's no phase shift, there's no vertical shift. Now what about amplitude? Now you want to say 1/2 because you're programmed to do that. But I want you to look at this picture and I want you to remember amplitude means what? Ceiling and floor, height. How tall is this room we're in? That's amplitude, okay? Take a look at the tangent. There is no amplitude. Nothing has amplitude except sine and cosine. All the rest of your curves are not contained in a room. They're all up into space. No amplitude. Now, does that 1/2 have impact on the picture? It absolutely does. It compresses it. So in reality, and I am not worried about this when you do your sketches, but in reality, this thing is flatter than a regular tangent. See how it's smashed down a little bit? It's a little curvier. I'm not worried about that for you. If you want to do that, great, super. But don't worry about that. There's no amplitude. The only time you really have to pay attention to that number is if it's negative. Because if it's negative, what will happen? It'll go upside down, right? So then you do indeed have to pay attention to it. But this number really, I'm not worried about in terms of a tangent curve. This is a really big deal though. What does that change? That changes where your asymptotes are, and that's a big deal because this affects your period. Now, what is the normal distance between asymptotes? This is a normal tangent curve right here. What is the normal distance between the asymptotes? How far is it from here to here? 1 pi. So the period of a normal tangent is 1 pi. So when I come over here and I put a 1/3 in here, that means I'll take my normal pi and divide it by 1/3, which means the period of my picture I'm graphing is 3 pi. Now here's the biggest mistake that's made. Kids will get that, it'll be perfect, and then they'll do this. What's wrong with that? That's 6 pi, right? The distance is 3 pi, so what are these going to be? Not 3's, they're going to be 3/2, or 1.5. 1.5 this way, 1.5 this way makes a total of 3. Everybody kind of seeing that? What's our frequency? 1/3 pi. Now, I want to caution you, when you write that, you better write it like that. Don't be writing it like this. That's not the same thing, is it? You mean 1/3 pi. So make sure that pi is in the denominator with the 3. Okay? we'll keep that sheet out. I hope we'll come back to it. I'll stop. I'll make myself stop, even though we have some really cool things to talk about. I'll make myself stop. So we can do a little bit more review today also. All right, I'm going to erase this now. Everybody okay? Those of you that have never done a tangent before, make sure this is somewhere in your notes. You want to know what this looks like. You got to know what a tangent curve looks like. As I erase it. Okay, now what are we going to do in 4-7? Today we're going to start 4-7. We've actually already done some of it. So there are just a couple of new things you have to remember. But we have already, believe it or not, done problems like this. I'm going to write a couple of them up here on the board. Now you're looking at that and saying, I recognize that button on my calculator, right? But we're going to find the exact values. And what that means is no calculator. So everybody in this room could press that in on your calculator and not have an issue with it. Okay, that's easy. We're going to do it by hand. Does anybody happen to know how we read this? Like if, let's say we're talking to Christina, who's still on vacation. We call her on the phone and we want to talk to her about this problem. How would we read that? What would we say, Patty?
I'm guessing it's the inverse sign.
Well, it definitely is the inverse sign. What does the inverse sign mean, Patty? That's what I'm saying.
I want to say it's flipped.
Well, the picture would be, you're exactly right, if we were to graph the inverse sign. What this is asking is, this literally says, find the angle whose sine is -1/2. So when Patty said inverse, what he meant was, normally what happens, I give you an angle and you give me the sine. Remember that? We draw the triangles, opposite over adjacent, opposite over hypotenuse, all that stuff, right? Well, this is the backwards. I'm giving you the sine and you're going to give me the angle. Okay? So when we see this notation, we know we are finding an angle. When I am using my calculator, if I need an angle, if my answer needs to be an angle, this is the button, these are the buttons I'm going to use. These are the buttons that find angles. If you press this button, whatever it says is an angle. All right, but I'm not using my calculator. I'm doing this by hand. So I got to find an angle whose sine is -1/2. Now, here is where things get a little bit tricky. Because actually, there are two angles. Well, actually, there are infinitely many. We'll talk about that in a minute. But in one revolution, part of my butterfly bow tie, there are two angles that have a negative sign. Think about it. Sine is which letter, X or Y? Okay. Sine is Y over R. Sine is Y. Sine is Y. I don't know how you're going to remember that. It's kind of stupid, but I remember sine, Y. They kind of have the same sound. I don't care how you do it. You can laugh at me, but I get the problem right. You've got to remember sine is Y, okay? Now, if sine is Y and sine is negative, then I should be focusing my energy down here. Would you agree with that? That's where Y is negative. So the answers, there actually could be two of them. There could be one over here in quadrant 3, and there could be one in quadrant 4. This is the tricky part of this lesson. There are rules that tell you if you see these notations, there are only certain places you're allowed to look. So I'm going to tell you what those places are. If you have an inverse sign, you may only look in quadrants 1 and 4. If you have an inverse cosine, you may only look in quadrants 1 and 2. And if you have an inverse tangent, you may only look in quadrants 1 and 4. So sine and tangent are 1 and 4, and cosine is 1 and 2. So this picture doesn't work now. I'm doing this problem right here. I'm finding the angle whose sine is -1/2. The rules established a long time ago by people way smarter than us, the rules say you can only look in quadrants 1 and 4. So I'm looking over there. That's where I'm looking. So I'm either going to have a triangle that looks like this or a triangle that looks like this. How do I know whether I want to look in quadrant 1 or whether I want to look in quadrant 4? Because there's only going to be one answer. Look, it says the sine is a negative number. Is that going to happen in quadrant 1? No, it's only going to happen in quadrant 4. Right? So I'm going to look in quadrant 4 for an angle that has a sine of -1/2. We've done that before. Do you understand why I put the -1 there and the 2 here? It's opposite over hypotenuse. What's this third side going to be? This is a special triangle. This third side would be √3. Now that's all hunky-dory, except I need the angle. How big is this guy right here? 30. Now here's another little bit of a change. The answer to the question is -30 degrees. If you say 330, would that name a coterminal angle? Would that basically be the same thing? It would, but it would be wrong. Because the rules with this notation, just like you have specific quadrants, the answers have to be, I always draw this half circle, because my answer has to be in that half circle. I can't be out of that circle, so I have to stay inside that half circle. When I come to do my cosine problem, I'm going to have to be in this circle, between 0 and pi, quadrant 1 and 2. I'm going to be right there. So whatever angle I give is going to have to be inside that circle. Whatever angle I answer here has to be inside this half circle, quadrant 1 and 4. Okay? So I get it. I'm tempted to say 330 also, but you can't. It's wrong. It's -30. All right? We'll do some more. This is tricky. This is the hardest part of the chapter, I think. Okay, so now we're going to do this one. All right? Things are getting kind of cluttered here. What does this say? What does this problem right here say in words? What am I looking for? Find the angle whose cosine is √3/2. All right, so we're going to find the angle whose cosine is √3/2. All right, so we have established that cosine is a top half function, top half, quadrants 1 and 2. I guess we didn't establish that, I just told you, those are the rules, top half, cosine. So you're going to draw a triangle either in quadrant 1 or quadrant 2. This number is positive. Shall you draw it in quadrant 1 or quadrant 2? 1. So I'm going to draw my triangle in quadrant 1. There it is. It says the cosine is √3/2. Don't have to worry about any negatives. So this side would be 1. And again, your angle is 30. And this time, the answer is just 30. So the answer to the problem is 30 degrees.
Why was it negative last time?
We were in quadrant 4. All right, here we go. Tangent, find the angle whose tangent is 1. That's what it says. Find the angle whose tangent is 1. Tangent is like sine. It's a right side function, so we draw on just the right side. That's it. These are my only options. That's a positive number. I'm going to draw one triangle. It's either going to be quadrant 1 or quadrant 4. It's a positive number, so it's going to be quadrant 1. And it says the tangent is 1. So wouldn't that be like 1 over 1? Which means that angle is a 45. And the answer to the question is 45 degrees. So before I erase all this and put some more problems up here, because we need to practice this some more, before I do that, there are 2 things that you really have to know. One is you have to know where these things are defined. Okay? So inverse sine is 1 and 4. And so is tangent. Inverse sine and tangent are 1 and 4. Inverse cosine is 1 and 2. Then you have to know when you draw your pictures, they have to be contained within that piece of the circle, of the revolution. So when you draw a sine or a tangent, whatever angle you name has to be either this or this, because it has to be in that half of the circle. Don't be drawing anything over here. Pretend that's not even there. So you can't go around like this. You can't do it. You can't be out here. And when you do a cosine, everything has to be contained within the top half of the circle. Okay? All right, let's have you try one now. I'm going to erase all this. You've got all this written down, or at least the important parts written down. So let's have you now try this one on your own or with your partner there that you're sitting with. All right, Patty, I want you doing this too, okay? To do what?
Like find the angle is.
Oh, you don't have to write that out, no. But I'll tell you the okay, so in a minute we're going to do this one with no calculator, and it really helps to be able to read the problem. But no, you don't ever have to write it out. I do just the first few times so that you're thinking. This means find the angle whose tangent is negative root 3. Okay, so bing, bing, bing. Into my head pops, okay, inverse tangent. Inverse tangent is on the right side, 1 and 4. I'm going to draw one triangle here or here. That's a negative number. Where am I going to draw my triangle if it's a negative number? Down. It's got to be quadrant 4. Kids, are you ever going to draw a negative in quadrant 1? No. Nothing is negative in quadrant 1. So you're going to draw this in quadrant 4. Butterfly bow tie. Always, always, always. Now the tangent is root 3 over 1, which means that's 2, and this guy is 60? Negative. The answer to the question is negative 60 degrees. Got it? one more before we do the doozy. Here we go. Now what does that say? Find the angle whose secant is -2. Okay, did I give you any rules for secant over here? No.
No, no.
So stop and think about it. If the secant is -2/1, then the cosine must be -1/2? Wouldn't you agree with that? If you have an angle whose secant is 2/1, then the cosine must be 1/2. Yes, especially if you're going to be using the calculator, because there's no button like that on your calculator, right? So it's always best to rewrite it in terms of one of the regular functions. Actually regular, one of the big three. All right, now cosine. Cosine's top half. So I'm going to draw a triangle either in quadrant 1 or in quadrant 2. How do you know 2? It's negative. If it's negative, you're not drawing it in 1, that's for sure. So the cosine is -1/2, which means this is √3. How big's my angle right here? Yeah, tell me what the answer to the question is. Not 60. Not 150. Not 130. Not -60.
120.
120! There we go!
There you go, Patty.
There's the answer to the question. It's 120 degrees. It's 120 degrees. Come on, you've seen that before. You've done that kind of thing before. If that's a 60, this has to be a 120, doesn't it? Where would -60 be? Somebody said -60. Where would that be? Quadrant 4. We're not even down there, so we can't have that. No. A half a revolution is 180. So if that much of a 60, the rest of it would be 120. Yeah, there's not really a rule there. You just kind of gotta think about it.
So would it be negative?
It'll be negative going on down.
Not going in that direction, it would be negative. No, remember, negative means going down. Now, Caitlin's issue over here, she's looking at this and she's saying, look, Mrs. Ford, that's a negative number. Shouldn't my answer be negative? And the answer is sometimes it is and sometimes it's not. But this time, no. Because a negative angle would be down here, wouldn't it? Be going this way? Am I allowed to be down here with a cosine? No. If it were a sine problem, I could be down there. But it's not. So I'm doing just a positive 120 because I've got to stay up there on the top. Okay? Now, last one, and then we're going to do some more review like I promised. Here, this says literally, this is what it says to me. If I'm talking to Betsy on the phone, because she's still on vacation, it says, find the tangent of the angle whose sine is 2/3. That's how I read that. Find the tangent of the angle whose sine is 2/3. So in other words, let's focus right here first. There's an angle out there that has a sine of 2/3. Okay? Now think of your rules. Your options are here and here. This is a sine. Since it's a positive 2/3, we'll draw it in quadrant 1. There it is. The sine is 2/3. Now wait, at this point, your little heart is starting to flutter. Because this would be √5. 9 minus 4. This is not a special triangle. So you're thinking to yourself, how in the heck is she expecting me to do this? I'm not. It doesn't say find the angle, does it? No, it says find the tangent. Can I find the tangent from this picture? I sure can. Tangent is opposite over adjacent. I don't need to know the angle. It doesn't say how big is the angle. It says, what is the tangent of that angle? So what would the answer be?
2 over root 5.
2 over root 5,
Which is 2
or
root
2
5.
root 5 over 5 when we rationalize it. See how cool that is? All right, so we'll practice a couple more of those next time we get together. But quite honestly, you can make a good start on the 4-7 homework now. We probably need to practice a couple more of these tricky ones, but you can at least make a good start on it.
So do you find the outside angle because it's in quadrant 2?
Yes.
Okay.
Remember, when you measure an angle, Peyton, you must start here. You got to start here. Okay, so that's 4-7. All right, so now let's switch gears again. We'll do a couple more on, I guess it'll be what, Monday? When I see you again. But let's come back and let's do a couple, we can do a few quick review problems here. So I'm back to my 4145 review, page 6 in my packet. Everybody good? We're looking now, we're ready for what, number 3? We're going to change 3 radians into degrees. Anybody remember how to do this? Pi over 180. I love you, Anna. Pi over 180. I would love you even if you got the wrong answer, but I love you more because you got the right answer. Pi over 180 equals 3 over x. Why is it 3 over x and not the other way around? Because you're finding degrees. And when you set this up, pi over 180, pi is the radian measure, 180 is the degree measure. So when you write this one, you have to write it the same way, right? So pi x equals 540 and x equals 540 over pi degrees. That's the answer to the question. I know you don't like the way it looks, but that's the way it is. Now we're going to do the same thing the other direction. We're going to change 18 degrees into radians. So what's that setup going to be? Same problem. Same thing. We're doing the same thing. So what's the setup going to be for 18 degrees? Pi over 180. That never changes. That's a fact of life. Pi over 180. X over 18. There we go. So 180x equals 18 pi, and x equals 18 pi over 180, which conveniently reduces to pi over 10. Good? All right, number 5, this is, okay, you look at that picture. And those of you that have been in here for, like last semester, when you look at this picture, what pops into your head? Arc length equals radius times radians. Exactly. Arc equals radius times radians. So those of you new to us, you might want to write that down. That's a biggie. That's our formula for finding arc length. Very, very simple to use. Now, question A says find S, and you can tell from the diagram that's the arc length. If the radius is 10 and the central angle theta is 10 degrees. Uh-oh, we have a problem, don't we? What's our problem? 10 degrees. What's the formula say? Radius times radians. Shoot, I have a degree. Can I change a degree into a radian? We just practiced that, right? So here we go. Step 1. Pi is to 180. Pi over 180 equals something over 10. Everybody okay with that? It's just what we did right here. So 10 pi equals 180x. I got pi over 18. Did I do that right? I'll stop soon if you hang with me here, folks. Otherwise, I may just keep you all day. Is pi over 10 or pi over 18 okay? So now I can answer the question. Arc length equals radius, which is 10, times radians, which is pi over 18. And we're multiplying those. So it's going to be 10 pi over 18. We multiply straight across, so it's 10 pi over 18, which reduces to 5 pi over 9. One more, we'll finish this one, the second part of this one. B uses the same picture, so we will use the same formula. Arc length equals radius times radians. So what do we know this time? We know the arc length is 2. I don't know the radius, but the angle is pi over 6 radians. So what?
Times 6. It divides by pi over 6.
Divide by pi over 6, which is the same as multiplying by 6 over pi. So I'm going to multiply both sides by 6 over pi. And the radius then ends up being, another multiplication problem, 12 divided by pi. Okay? Well, we're almost done with that sheet. Hang on to that. We'll finish that next time. Everybody should be able to do 4.6. Please get that done. You should be able, really, to do most of 4.7